sugars, hemp seeds to food, as well as the extracts into medicine. So what I'm going to talk about is more of a macro perspective on where the industry is at today and where we think it's going in the future. Got it. So, people talk about hemp, people talk about marijuana. We, and I think most of the audience agrees that we're talking about a singular plant that's very adaptive. And the four legs of the stool that we see in this industry, the two low-hanging fruits are the THC processing, spurned by the marijuana industry, and secondarily the CBD processing using industrial hemp strains. The difference legally is that 0.3% THC, and we can talk a lot about that, but that is the law today. And in that case, we ended up processing mostly CBDs rather than marijuana, very analogous processes. And I'm not going to talk too much about that right now, but that is clearly the low-hanging fruit. And when we talk about the resources coming into this industry and the money, this is where it's landing. However, note that this is a very small fraction of the plant itself. And when we look at the long run and we look at the actual biomass out there, what we're really talking about is the hundreds and thousands and tens of thousands and millions of acres of hemp that are going to be grown for medicines, but also for seeds. And what are we going to do with all that biomass? So my company, PureHemp Technology, really has focused on the refining of the hemp stalks and using both traditional processes to get the fiber, but we've developed a rapid processing technology that deconstructs the hemp stalks into these fundamental pulps, sugars, and lignin, which become the biomaterials to, once reconstructed, can create any product that's now made with oil, can be made with plant-based materials, including hemp. So this is the focus of our company, and I'm going to talk a little more about that. From the point of view of food, a industrial hemp variety that is seed-based rather than CBD medicine-based, 30% or more of the plant is the seed. So it's a significant part of the biomass, and we see the seeds as a platform not only for multiple types of food, products and nutraceuticals, but the core derivatives of the seeds are the hemp hearts, the hemp flour, the hemp meal, and hemp oil. These themselves are all products. So our small little company based in Fort Lupton, Colorado, not too far from here in Weld County, has been involved in everything that you see here with the exception of the THC processing, which is very analogous to the CBD processing. So I'm going to be talking about the big picture of what in the biorefining industry they call biorefineries, but in the hemp industry we call them hemp refineries. And what you can see here is the multitude of pathways of different products and different applications once you deconstruct or separate the various components of the plant. And as you can see at the very bottom corner there, CBDs, THC, and other cannabinoids is a very small portion of the plant and the many applications. And we're seeing most of the resources going into that low-hanging fruit because of the tremendous impact of that medicine, because of the human brain needs of THC. But over and beyond that, what we expect to see is a expansion of the industrial applications as well as the food applications as the markets for medicine become saturated and as we see a consolidation of that aspect of the medicine industry. I just want to draw your attention to, on the right side, lignin, which is, from the point of view of biomass and from the point of view of hemp stalks, a super material that heretofore has not been able to be utilized. Lignin accounts for between 20 and 25% of all biomass, that is the stock, and it is a material that can be used to create just about any kind of plastic in the world. So this, from an industrial scale, is essential for the bioeconomy in terms of substituting oil-based materials and petroleum-based and fossil fuel-based materials with bio and plant-based materials to make bioproducts. All biomass has sugars, and these sugars can be converted into not only food and fuel, but into many different kind of chemicals. And of course, we have the traditional fiber applications in the pulp and paper industry, in the specialty chemical industry, in the nanocellulosic industry. These materials, pulp, sugars, and lignins, are the basis of the super materials of the future. And this is why my company is investing in not just processing the medicine and extracting the CBDs and other cannabinoids and doing downstream processing and cleanup, but really looking at the whole hemp plant and how we can have the utilization of the plant for much higher value uses. So I don't have to talk too much about the flower here, because I think the audience knows, even though it's a very relatively small part of the cannabis plant, it has today, because of the legal structure, two sides to it. One is the THC rich cannabinoids, marijuana, and there is a big distinction of what's going on in legal states and unlegal states. We have this whole industry really started and has been driven by the underground marijuana movement, which is now in 4 states, not underground anymore, and certainly with medical marijuana, a majority of the states now have medical marijuana laws. So from the THC derivatives, there are many, many products. All one has to do is go into the pot stores here in Colorado, in Washington and Oregon, and see the diversity of downstream products that are made. An old-timer like me was really surprised to see that over 80% of the products sold in pot shops are derivatives, and only 20% are actually the plant itself. So this is where we see a significant boom in this side of the industry. On the other side, the CBD-rich side, we are somewhat limited by the laws that restrict a processor like PureHemp technology to take in anything with over 0.3% THC in Colorado. But what we do is we process CBD-rich strains into an oil that preserves the complete cannabinoidal profile, and then from that oil, which is 74% cannabinoids, 64% CBDs in the strains that we're using, we use that oil to manufacture other products, including extract products and other derivatives to go to distillates and isolates. So when we talk about seeds, I mentioned that a seed-rich plant is over 30%. Most people who walk into our door, no matter how smart or experienced they are, they don't know the difference between seed oil and the cannabinoid oil from flower. So the cannabis plant produces 2 oils. The seed produces a non-THC, non-CBD, non-cannabinoid oil, very healthy, very rich. But the flowers produce the cannabinoids, and once concentrated, that becomes an oil. Maybe you all didn't know that little tidbit of information there. We have a venture now that is developing a hemp seed to hemp food products division, just like there's a tremendous amount of growth in the medicine side today. To a lesser extent, we're also seeing exponential growth in hemp food and beverage products. And they just range from the bars the pasta, and in some markets you just can't get enough of it. This year, many of our growers that were providing us seeds had their crop test hot. So this is one of the big barriers that we see in the industry, with the incredible encroachment of the legal entities, and in addition to the FDA, making it very difficult for not only on the marijuana side but on the industrial hemp side to bring a harvest in, and for farmers to get us those seeds so that we can process them into healthy food products. This is something that I think is going to grow increasingly, but it's not going to match what we're seeing in the medicine today. So I mentioned that stalks are over 70% of the plant, and the question that farmers have, whether they're in the San Luis Valley or New Mexico, is whether they're growing medicine or whether they're growing seeds or whether they're growing, is what do we do with the stalks? And there are, of course, traditional industries that over many thousands of years have used the fiber from stalks to make textiles, to make ropes, to make cordage, to make sails. More recent in our human history, we see the seeds coming into play to make oils, to make food products. But in the case of textiles, most of the textiles coming from the stalks, these textiles, these woven materials, are coming from China. China has over a $300 million infrastructure that will take a long fiber from the hemp stalk, known as bast fibers, B-A-S-T, which represent less than 15% of the stalk, and convert those into mill-ready textiles. So today in China, they can do that with low labor and significant infrastructure. Today in North America, we can't. Now, there are technologies on the horizon. They're called decortication. These are decorticators separate the long fibers from the short fibers, and there are companies that claim that their decorticators will provide mill-ready fiber. I don't think this is the case in the near future, and that those people in the hemp industry that are talking about converting those stalks into clothing are going to have to regroup and rethink that, in my opinion. One way that we have found to accomplish textiles from the hemp stalk is, instead of preserving the long fiber, to deconstruct it and then reconstruct the fiber in a rayon-like process to make non-wovens. So people that have tennis shoes on or baseball hats, these are examples of non-woven fibers. So we can still get to textiles, hemp textiles in this country in the near future without going the way of wovens and having to create a $300 million infrastructure to get there. In an advanced process, these pulps can be used for many different things, not just, as I mentioned, a non-woven pulp, but they can also be used for making a multitude of different higher value pulps, including nanocellulose. And these nanocellulose materials, which is microcellulose particles, again, are materials of the future. These are the materials that are going to be going in cars. These are the additives that are going into concrete that's going to make them twice as strong as hemp or fiberglass that's not processed. There's going to be tremendous amount of applications for these new generation of fibers as the technology takes off. Today, we cannot really take more than a couple of 100 tons of stalks because of our limited capability. But as the infrastructure grows, as money begins to come into some of these other aspects of hemp processing, other than processing the medicines, we're going to see a proliferation of processing facilities across the country where hemp is legal to grow. Down here is an example of paper towels and toilet paper made from pulps produced in our equipment in Fort Lupton, Colorado. So I mentioned lignin. The pulp is between 40 and 50% of that of the plant itself. Lignin makes up 20%, and if there's a takeaway from this presentation, it might be you've never heard of the word lignin. Lignin makes up 20 to 25% of all biomass, but heretofore it's never really been able to be used because the available refined lignin on the planet is coming from the pulp and paper industry, and because of the chemicals used in that industry, the lignin comes out of the process very polluted, very large molecules, and large molecules do not permit the lignin to be formulated into products like terephthalic acid as an example, which is used to make plastics. So coming out of an advanced technology like we have developed, the lignin comes out very pure, low molecular weight, very reactive in the product manufacturing area, so that in addition to being able to use as binders, adhesives, we really have the opportunity to substitute lignin for oil to make consumer and industrial products. So the examples coming out of our machine of what we will be doing with lignin are include producing vanillium, which is an alternative to vanilla. And you can take this lignin and make an alternative to vanilla. Also, terephthalic acid, anybody who has a PET container here or a plastic bottle should note that over 70% of that bottle is made of terephthalic acid. Nearly all the terephthalic acid on the planet today is made from oil. Lignin can be substituted for oil to make terephthalic acid, so that what we can have if we use the hemp sugars to make ethanol, then refined to ethylene, to polyethylene. The other third of the bottle is polyethylene. We can have a beverage bottle made of 100% hemp. So this is kind of on the forefront of what we're talking about with using lignin, the second largest polymer on the planet, and substituting lignin and plant-based materials for oil-based materials. Okay, so we talked about pulps, which is the cellulose fraction of the plant, the predominant one. We've talked about lignins, which is about 20% of the plant. The remaining plant, after you deconstruct it, are sugars. And these sugars have many different applications, especially in the nutraceutical industry. The specific, what they call C5 sugars or carbon 5 sugars, the majority one is a sugar called xylose, and xylose is relatively easy to convert into xylitol. Some of you may be familiar with xylitol. It's the healthy sugar that goes in toothpaste and in mouthwashes. It doesn't decay, and it's just an example of one of many, many products that can be refined from the sugar stream of hemp stalks. In addition to having these C5 sugars like xylose, the pulp fraction, that 40% pulp, can be converted into sugars as well, predominantly glucose. Glucose is a intermediate to go to ethylene. Ethanol, polyethylene is one example. So in a sugar platform, we see well over half of the stalks being able to produce many different kinds of sugars. So these are, again, materials of the future that come from the hemp plant. So to give everyone just a sense of what I'm talking about in terms of what is the future of utilizing this plant beyond this stage right now where there is almost a complete focus on the medicine part. Where is this industry going? With the increasing hazards resulting from climate change and the resulting political action with will to move from oil and carbon-based to plant-based economies. This bottle, the PET bottle, is one product, just one product of thousands that can be produced 100% from hemp and replace oil-based materials and oil-based plastics. So PET containers, polyethylene, terephthalic acid, that's the ingredients to make the bottle. And you can see there that 33% of that bottle is polyethylene. So the sugars from the hemp stalks, or sugars from really any biomass material, can be fermented and then used to make ethanol. And this ethanol is used as the ingredient to make the polyethylene of a PET container. The same is true with terephthalic acid, with the exception that it's another chemical pathway. We take the lignin and have a pathway to terephthalic acid. And you can readily see that by using the sugars and the lignin from the hemp stalks, we have the ingredients of a 100% plastic bottle that can replace oil-based bottles. So it's an amazing story, but it actually is more encompassing than that when you look at the incredible applications of the hemp plant. Specifically, the beverage that goes inside that 100% hemp-produced bottle are sweetened with hemp sugars, like a xylitol or a glucose. And even better, a alcoholic beverage can be produced from the hemp sugars to make ethanol, which is alcohol, that can also be added as an alcoholic beverage. And I'd go back to the previous presentations that we can also add the CBD and some cannabinoids to that product. So you can see that this one bottle with the different ingredients coming from the incredible hemp plant is revolutionary. And as a footnote, the label that goes on that bottle is made with hemp pulp that's been produced from the stalks, and even the inks and the dyes can be made from the lignin. So this is an example from our company's point of view of the future of the full utilization of the hemp plant. There's a question there.
Are you making these water bottles now?
Pardon me?
Are you making the bottles now?
No, we're not. We are intermediate processors. What we're making is the lignin, the sugars, and the pulps. In the case of the pulps, we send the pulps out to make paper. In the case of the sugars, we do ferment those in our laboratory and distill those into an alcohol. But as intermediate processors, what's lacking in our sector is the green chemists that have been so involved in oil chemistry that they and their companies have not converted to green chemistry. So the pathways are very similar, but to go from PET from polyethylene, the state of the art today is the industry is using sugars that are made from corn starch. So we have not gone as an industry into using the cellulose to make the polyethylene. So that's what's lacking, and hopefully that addressed your question.
How much do you think it would cost to build a machine that makes this bottle?
I'm sorry?
How much do you think it would cost in terms of capital outlay to develop and build a machine that can make this bottle?
The infrastructure to develop a product like that is hundreds of millions of dollars, and that's why we don't have takers. On the other hand, there are niches in the plastic market that don't require that kind of infrastructure, and specific type of plastics can be produced today, but what's lacking is the will of the so-called sustainability companies to take their R&D budget out of the advertising budget and actually do R&D so that the so-called sustainability companies, instead of waving their flag, hey, we have a green bottle made out of cornstarch for 30% of it, actually go all the way to a hemp-based product. So your point you bring up, there's a big lack of infrastructure. I'm sorry.
Can you use pre-existing infrastructure?
Yes, you can use pre-existing infrastructure, but it's again going from petroleum-based chemistries to green-based chemistries that have most of these industries have forgotten with the advent of cheap fossil fuels. Yes, sir.
So I love xylitol, and I get mine from the birch tree, and I pay much higher than if I would have gotten sugar cane. I buy it because of all the billion reasons other than the fine sugar. Have you worked with that industry that's already extracted from the birch tree to make xylitol?
The answer is, well, the question is, relates to xylitol coming from plant-based matter. Most of the xylitol being produced on the planet today is coming from maple and birch trees, a lot of them from England, from Europe. The point is that the process to make xylitol is well known. There's no new technology that's available. The sugars that we derive from the hemicellulose fraction of the stalk are comparable to make xylitol, so it's another source of material to make the xylitol. The goal is not to take xylitol from the conventional industry. The goal is to take the sugars from hemp, use conventional technology to make.
Making xylitol with the birch tree, and I've got a hemp farmer that can produce a lot more faster than how long it takes to grow that birch tree. Can I just either get a birch tree delivery or a hemp delivery and run it through my process to make xylitol the same?
Yes, the xylo sugar coming from the maple, the xylo sugar coming from the hemp is comparable. So that's your ingredient that then goes into a hydrogenation unit to make the xylitol. So in terms of creating, most of the xylitol is made in China or made in Europe. So this is an
There's a big company that's probably about a lot of money. They harvest the trees, I think, from there, but that's where they produce it. It's all U.S.
and there are some producers here, but the point is that this is a potential application, one application of the C5 sugars from the hemp plant.
Do they know about this possibility? Like, I follow xylitol forever, and I've never seen this until yesterday.
Well, we have entrenched industries, and an analogy would be in the pulp and paper industry. Does the pulp and paper industry know that they can make pulp out of agricultural residues? Yes. Are they willing to move to agricultural residues because they've got hundreds of millions of dollars of infrastructure and on a less sustainable pathway to pulp? No. So this is where the market has to push. This is where the supplies have to be available. This is where the infrastructure to be able to produce pulp economically to compete with forest pulp has to be in place. And at the end of the day, hemp pulp is going to be more sustainable, but until we have an infrastructure to get to some level of industrial production, it's going to be more expensive. Now, the saving grace...
It already is being industrially made for xylitol here in the U.S. So if I'm the owner of that process that is industrialized it and said, I order it by the pounds, but I give it out to the family. It seems like it'd be very easy for them to start accepting hemp.
It is. It is. We got our work cut out for us.
Agricultural the whole way, so they don't even have to make the jump from petroleum. They're not using petroleum.
But the point is, in terms of substituting, there has to be the supply and the infrastructure to extract that xylose from the hemp plant, and that's what's lacking. If you were to come into our corporate office in Fort Lupton, Colorado, you would see these hemp sugars and you'd see the hemp lignin. As far as I know, we're the only company perhaps in the world where you can walk in and see this lignin, this super material. So we're a little ahead of the game. But I think you make the great point in terms of substitution. That's going to be the direction, but it's going to require an infrastructure to get there. Okay, so this is something to think about. Yes, sir.
Do you have any statistics on fiber, refined fiber from the hemp plant, and in terms of fiber reinforced plastics, and how that compares to carbon fiber reinforced plastics and the strength and all the different characteristics?
So the traditional use of the hemp stalk is as a fiber. And there are many fiber applications and in the plastics industry, and one of those applications is as a binder, and most specifically in the building construction industry and the hempcrete industry. In these concrete and these hempcrete, you need a binder, and you need a material that will provide strength against cracking. So the question that was asked was, does the hemp fiber have a benefit over a traditional fiber additive such as fiberglass? And there's a twofold answer to the question. The first answer is yes, and that depending upon the application, and they could be fiber-filled extruded plastic would be an example of a hemp fiber application in the plastics world.
Printing, for example, I think there's some types of that around now.
Another example would be in concrete, where they're putting fiberglass in to prevent cracking. So hemp definitely has an advantage there. With 10 to 20% of strength is what we're seeing, and longer life and less cracking. So there is a definite advantage. One of the barriers to that application is the testing, the liability issue. So that is beginning to move in the marketplace. Hempcrete houses are being built, but you don't see pre-stressed hempcrete buildings anywhere because of these issues. I said there was a twofold answer to the question. The first answer is traditional fiber, not really processed, but size reduced, added to composite plastics or added to concrete or asphalt. The second part of the question is, if that fiber were processed in an advanced technology like we have, where the lignin part of it is removed, the sugar part, and you have so to speak, a cleaner fiber. What we're seeing on an experimental basis is that processed fiber versus raw fiber as an additive not only will increase the strength and increase the characteristics that these manufacturers are looking for, not by 10 or 20%, but by 200 or 300%. So you have a plastic or an asphalt or a concrete twice as strong. All of a sudden, applications heretofore for these materials become more readily available. As an example, pre-stressed concrete as opposed to non-stressed concrete. So the answer to your question is yes, but if you process, you will find greater strength and attributes of fiber in composites or in concrete, but that once processed, that fiber, the strength factor goes up 100-fold. I'm sorry, 200-fold. Okay, so if this is all so good and this is all so great, why aren't we seeing these resources come into this industrial side and not the medicine side? And from our point of view, there's really 4 circles, if you will, to this industry. There's agriculture, there's intermediate processing, taking stalks to pulp, sugars, and lignin, and then there's final product manufacturing, taking these intermediates, whatever they are, to final products. What is driving all of that is the consumer demand, but what's lacking, unlike the marijuana industry and now the medicine industry coming from industrial hemp, is the infrastructure. I made the point that why I don't think we're going to have hemp textiles in this country for quite a while is because we don't have an infrastructure to go to a mill-ready fiber. So we're going to have to do things differently. We, as biorefinery developers, don't have the capital right now to build these refineries. But as you know, what we're seeing, particularly from the agricultural side, and a great example would be the San Luis Valley here in Colorado. For those of you, who aren't from Colorado, it's the second biggest valley in the state, and it's one of the more productive valleys, and the farmers down there have been very aggressive in producing hemp, mostly for seeds. But now the calls that we're getting into our office is, what do we do with the stocks? So finally, the alliances, the stakeholder groups are coming together, realizing that to build processing facilities, somebody's got to put money on the table. And finally, that's beginning to happen. But until we can get these processing facilities set up near the field to mitigate the transportation costs, nobody's going to know what to do with the stocks. They're going to have a relatively low value, such as animal bedding is an example. And what we need to move our segment of the industry forward is the infrastructure, the processing infrastructure to provide the farmers a income from their secondary crop, the primary crop being seeds or medicine, but then the stalks become secondary, and as a process to produce these super materials that become the ingredients to the bioeconomy that is now emerging. In addition to that, what we're lacking is the sales and marketing, and that's going to come with the financing. So from the perspective of the whole hemp plant, we recognize that today the excitement, the action, the money, it's all about the medicine, and we get that. We have gone into the extraction business. We have a full extraction facility in Fort Lupton, Colorado for industrial hemp-derived CBDs, and we make our own line of products, and we kind of got pulled into it because this is where the money is, and I say pulled into it because we had to come down from that vision of utilizing the whole hemp plant and not only producing a medicine that's hot today that may not be hot tomorrow, or the prices may go down so substantially because of the competition and so many people getting into it, that the markets, the dynamics are going to change in perhaps a boom-bust cycle, certainly for the small producers that aren't vertically integrated. We believe that the future is the whole hemp plant and being able to process stalks into valuable products and seeds into food products, in addition to the cannabinoids being processed into medicine. So we're in Fort Lupton, Colorado, near here. Anybody who is interested in what we do in processing the whole hemp plant, please feel free to contact us. And if you're interested in seeing, some of these processes in place at a continuous scale of a half a ton a day, where we can take in a half a ton a day of hemp stalks and process it on a 24/7 basis continuously. We'd love to show you that, as well as our extraction operations. If there are any questions, I'm happy to answer them. Yes, ma'am.
What's your extraction process? Does it leave solutes in the final product?
We came from this industry. I have my little sample in my coat pocket. I left it out. We came from this industry kind of from high tech, from cellulosic biorefining. When we made the decision to get into extractions, we came to the conclusion that the best process from the point of view of medicine is an ethanol extraction process. So we developed a pretty extensive batch ethanol process and now make a line of products called PureHemp Botanicals. Our unit operations recover all the ethanol. In fact, from the technology that I described before, we produce our own ethanol. So we're capable of not only recycling the ethanol used in the process, but we're able to produce the ethanol from the sugars of the stock. So it's a pretty amazing process, and there's quite a story there.
Sorry,
6-month schedule. We have a Q&A later. So-
Okay, great.
so
Well, you've been,
any other questions, we'll just take at the Q&A.
you've been a great audience. Thank you very much.
Thanks, Joe. Appreciate it.